This is something that's not a typical computational thing, but is still related. I've been experimenting with probability and statistics here, and I've had some ideas. And so, the first idea I had was, what if you could encode the probability of a bit being on or off as the memory type, and so that if you had redundant memory cells, and a percentage of them were on, then that percentage would be the stored quantity. Or if you could have a weighted or a set of weights that could lead to the probability that you could run the random number generator through. But to demonstrate, I have this component here. It is the random number generator wired to a regular memory bit. This is to clear the bit. This is to implant a 50% probability that it will be on. And these two are to manipulate the probability. This one cuts the probability of it being on in half. And this cuts the probability of it being off in half. And so if I were to plant a 50% probability, and then double the likelihood that it, or half the likelihood it will be off, that's a 75% likelihood that it will be on. And so if I show it, it is on. And if I were to do that again, well, that time it was off, but this time it will likely be on. And the next time, and if I keep repeating this process, I can build a probability table that will show the exact 75% to 25% probability, which is why I thought perhaps a table of or a set of weights just like these that are stored in the memory that are used as instructions for the random number generator to produce the percent probability. And so that could be used for storing very precise numbers. But then I also considered that storing so many weights in normal binary memory would be very similar to just storing literal integers. Actually, while we're here, let's experiment with the inverse. 25% likelihood of being on. Yeah, very interesting. But over here, this displays actually what's happening with these weights. So each time you each time that you cut the likelihood of it being on in half, which this time this bit here shows it 3 nested. So this is the regular 50% likelihood stream. This is the 25% likelihood of being on stream. And this is the 12.5 and the 6.15 or 6.125, something like that. And so this has a very small likelihood of being on, but it's also a measurable likelihood if you can continue to do something like this here. And so this is actually the sort of weight system I thought of. And this, if you were to actually invert the stream, would be synonymous to the opposite if you were to cut the likelihood of it being off in half. And so that's a whole nother field that you could populate. What else? I also have this secondary area here that I've constructed. This is the memory bits in parallel that all take a 50% probability. And as you can see, it is orbiting around 50% on for all of them, but it has a lot of error, and that's because there's so few of these cells right now. If this were 100 cells, the probability would be stored a lot more accurately. But you can also see how these functions would work. And also how radically these functions are capable of changing the data, and also how unpredictable the effect could be with so few memory bits. But I actually set up this graph right here to visualize and auditorize exactly what's going on here with these operations and probabilities. This is looking at the probability while it's happening. And notice how the bottom bits occur very regularly, and the middle bits occur occasionally, and the upper bits occur only once in a great while, as is per plane, of course. And the way I've done this is also over here. I've ANDed the 50% probabilities so that you would need 50% of one and 50% of another. So 50% of 50% would be 25%, and I just continue that process. And that's all I've been doing recently. I'll be getting back to some other components sometime soon.